Welcome to Developer Bros. My name is Ritu, and today in this guide, we go deep on the Model Context Protocol, what it actually is, how it works under the hood, and then we build a real server in Python with FastMCP. It is beginner friendly, but we will not skip the technical detail. By the end, you will understand the architecture and be able to ship your own MCP server. So, what is MCP? It is an open standard that connects AI applications to the outside world, your files, databases, APIs, and tools. The analogy that sticks: MCP is a USB-C port for AI. Before USB-C, every device had its own connector. MCP gives every AI app one standard plug for data, tools, and workflows. Before MCP, every AI app integrated with every tool through bespoke one-off glue code. 3 apps times 3 tools is 9 separate integrations. In general, it is M times N, and it grows quadratically. Every new tool means rewriting connectors for every app. It does not scale. MCP collapses that. Each app speaks MCP once. Each tool speaks MCP once. They meet at a shared protocol in the middle. Now it is M plus N, not M times N. Build your server one time and every MCP compatible client can use it. That is the whole promise. Build once, integrate everywhere. Here is the architecture. The host is the AI application you use: Claude Desktop, an IDE, a chatbot. Inside the host live one or more clients. Each client holds a dedicated one-to-one connection to a single server. The server exposes capabilities and talks to the real world: databases, APIs, the file system. Key rule: one client, one server, one stateful connection. A server exposes 3 kinds of capability, and the difference is who controls them. Tools are model controlled. Resources are application controlled. Prompts are user controlled. Remember that control axis. It shapes everything. MCP is bidirectional. The client also exposes primitives the server can call back into. Sampling lets a server ask the host's LLM to generate a completion. Routes tell the server which directories or URLs it's allowed to operate on. Elicitation lets the server pause and ask the end user for input mid-task. These callbacks make servers far more powerful. Underneath every MCP message is JSON PC 2.0, a simple, well-understood spec. There are exactly 3 message shapes. A request has an ID and expects a reply. A response carries either a result or an error. A notification is fire and forget. That's the entire wire format. FastMCP generates and parses all of this for you. Those JSON-RPC messages travel over a transport. 2 matter. Studio runs the server as a local subprocess. Zero network, lowest latency, perfect for local tools and desktop clients. Streamable HTTP is for remote servers. Use Studio locally, HTTP when the server lives elsewhere or serves many clients. Every connection follows a lifecycle. The client sends initialize, the server replies, the client confirms with an initialized notification. The handshake is complete. Now the operation phase begins. Finally, a clean shutdown closes the transport. Capability negotiation upfront is why a client never calls something the server didn't advertise. That's the protocol. Now the easy part. You almost never implement it by hand. FastMCP is the standard Pythonic framework for MCP. You write a normal Python function, add a decorator, and FastMCP handles the rest. This is why FastMCP powers the majority of MCP servers in the wild. Here is a complete working MCP server. Install FastMCP, import it, create a server, add a tool, call mcp.run. That's it. 8 lines and you have a real MCP server. Let's break down each piece. Tools get richer fast. Annotate parameters with types. FastMCP converts the signature into JSON schema. The doc string becomes the tool description. Good type hints and a clear doc string are the difference between a tool the model uses correctly and one it ignores. Resources expose read-only data, each addressed by a URI. Static resources always return the same data. Resource templates introduce parameters into the URI. Think of resources as a typed addressable get layer over your data. Prompts are reusable parameterized message templates the user invokes deliberately. Decorate a function with mcp.prompt. Its arguments become template parameters. This keeps your best prompt engineering versioned and shareable. Tools are for the model, resources are for the app, prompts are for the user. Two ways to run. Use mcp.run in code or use the FastMCP CLI. Connect from Python with the FastMCP client. Add your configuration to Claude Desktop. Restart the host and your tools appear. That's the full loop. Build, run, connect. Going from prototype to production adds 4 concerns: auth, testing, deployment, observability. Each solves a different production challenge. Build with FastMCP, scale with a gateway. Everything you need to keep going. Start with the FastMCP docs and the MCP specification. Read real servers, study examples. Build something this week. That's the best way to make all of this stick. Thanks for watching.